All right, so review for summative number 5. We're going to try to get through all the A's if we can. So number 1, we're going to type our function in our calculator into y equals. We've already done that. And then we're going to graph it in this. Oh, I do not have the standard viewing window. So a quick way to get back to our standard viewing window is to go to Zoom and choose 6. Very good. There we go. And we're going to have to find all the x-intercepts, any maximum bumps, and any minimum bumps. So what I would like you guys to start doing is estimating where the x-intercepts are. I'm going to estimate that this one is at roughly like negative 0.6, negative point something. So when I go to choose my command on my calculator, I am choosing for x-intercepts, it is where the function comes out to a value of 0. So choose the 0 finder. And I want to give a value that I know is to the left of where I think it is. So I'm going to go -1. And then to the right of it, I'm going to go 0. And then the guess is somewhere in the middle there. Pretty good guessing, guys. The first 0 is at, if we round to the tenths, negative 0.7, 0. What happens if your calculator gives you that E thing? That means 0. Very good. So we got to do this all over again. Okay. Now I should have made a guess before I started, guys. Where do you think this x-intercept is? 1.2. Sounds good. So something slightly to the left of it would be 1. Something to the right of it would be 2. And then guess, just to enter 1. Very good guess, and 1.3 it's actually at. And then that last one, make a guess for me.
2.8
packets. Maybe back there. I might have cleaned up on Friday. All right, we're guessing 2.8. All right, let's find it. Calc 0. So 2 is definitely to the left of it. 4 is most definitely to the right of it. That would be super to the right of it. Very good guess at 2.8. Don't guess. Now, I think on the test I designed it so there's only one x-intercept, so you only have to find one of them. So humor me and find it. All right, this little bump right here, would you refer to this as a maximum or a minimum? It's a maximum. Give me an estimate for the ordered pair where it's located. 0.2, 5 point something. Okay, sounds good. So the 0.2 is the part I'm interested in because when I do left bound, right bound, and this is a maximum, make sure you pull up the right command. I'm referring to left and right of that x value. So something to the left of 0.2, I'm going to go -1. And then something to the right of it, I'm going to go +1. And then enter for the guess. And I do need to write out the full ordered pair, so we're going to write, very good guess, 0.2, 5.1. Was that really a guess, or did you already find it?
I mean, you asked if I did my homework.
Wow. Good job. No, that's just, that makes me, I feel like I should give you a shout out now.
Hey, where's my sticker?
I just want the world to know that David L. did his homework like I asked. That a kid. Shout out to David's mommy. All right, minimum finder. Oh, fun fact about my stickers. Someone dropped hand sanitizer on the entire pile of my stickers and ruined them.
Do you know who?
The llamas. So the only ones I've left are unicorns. I cannot even tell you how feisty I was when I came into school on Friday and they were all ruined. All right. No. Minimum finder. Thank you for bringing up that bad moment. Now I'm really crabby again. Minimum. All right. This is approximately 2 point something. So something to the left of it would be 1.
I'm going to guess 2.2 and -3.2.
Oh my gosh, you are such a good guesser today. 2.2, -3.2. That's good. We're finding the minimum on number 1A. Yeah, so last time we tested this, that increasing and decreasing interval was a problem. That is 100% accurate. So what I like to do after I have this graph, just sketch something kind of, it's not going to look great, guys. Just give yourself a sketch on your review here. The problem is a lot of you guys didn't tell me the right values for your interval. I'm asking when your function is, let's do the decreasing part first. When is it decreasing? It's from this time value to this time value. So when is this point right here? What x value was this? How far over was it? Is this 0.2 or something?
Yeah.
So it's decreasing from 0.2 to when? I don't know what this was. I didn't write it down. The x value is 2. We just found it. Oh, guys, it's right here. There. 2.2. 2.2. So here's what I do, and you'll notice it on my key as well. When I write this stuff down, because I also often give the wrong part of the interval. So when I write down the maximum of, what was this, 0.2, comma 5.1, and this was 2.2, negative 3.2. What I do is I like underline or highlight or circle these two numbers right here, because those are the ones I'm supposed to use on the next part of the question. Last time you guys, a lot of you used the y values, and that's where you got marked down to a 3. So we just decided that the decreasing interval was from 0.2 to 2.2. So the increasing interval would have been from negative infinity to 0.2. Oops, 0.2. Hello. And then there was another interval where it was increasing. Where did it start up? X value, man. 2.2 to infinity. There you go. So I might suggest after you find these max and mins, highlight, circle, underline something, those x values of the max and min. I think that'll help. All right. Otherwise, besides the interval stuff, I think that question actually went very well. I knew the interval would be a problem, so hopefully it won't be a problem again. All right, this is another repeat section, so go down to 2A. We're graphing exponential functions, and I tried to create a question where you knew what I was asking specifically, like you have to fill it out. So this says 2/3 to the negative x power. What is the base? And think before you speak.
3/2.
Yes, it's 3/2. Why is it 3/2? The negative exponent gives you a reciprocal base, so this is 3/2. If you guys would rather think of that as 1.5, you can. So tell me if that's growth or decay and why. Talk like a big kid. It is growth because the base is greater than 1. Now guys, I think words would be more effective here than mathematical symbols. Some of you tried to do some symbolization with greater than and less than symbols and it backfired. So just use words, okay? All right, moving along. I'm going to have you graph some exponentials. Oh, but first, let's talk about the shifts. If this is our original function, 7 to the x power, what would my new function, let's call it g, what would it look like if it was shifted right to? What changes? Where does the plus? No, -2. And where's it located? Up in the x in the exponent. So x -2 is a right 2 shift, and then what indicates an up 9 shift? +9 off to the side. Very good. So you're going to be creating a new function based on transformations. 4a, we can actually get 4a done like. We're going to be lazy math graphers right now. I am not going to pull my graphing calculator up because I'm just too darn lazy. But I'm going to give my teacher some things to look at so that way she can give me my credit. Where is the horizontal asymptote going to be located in 4a? Positive?
Yeah.
-4. So down here at -4, I'm going to take a highlighter or something. I'm going to draw like a little line here. Or that was supposed to be a line. And that's at least a visual boundary for me. But it's also like an indication for my teacher that I do know where the horizontal asymptote is located. While we're at it, I'm going to write that right down here. Y equals -4. Is this going to be growth or decay? Yes, it is growth. Can you tell me why? The base is greater than 1. It's a 5/4, which is like 1.25. So from here, I don't really need a beautiful graph here, guys, on our review packet. Can you just draw me what essentially is a basic growth graph? Lovely. As long as that little tail end is going along the asymptote like it's supposed to and you didn't go through it, you're good to go. Domain. Domain is left to right. Negative infinity to infinity. Now, you might be confusing the new logarithm graphs. Yeah, so we got to be careful here. Range. -4 to infinity. So one thing I noticed is the asymptote line, the equation for the asymptote, the beginning of my range, they're all the same number. Let's talk about the end behavior. Yeah. So I know I want left and right end behavior. Talk to me about the left side of your curve. Where is it traveling? To the -4 asymptote. Very good. How about on the right side? Up to infinity. Very good. Good, good, good. Yeah, the vertical. Yes, yes. So when we get to the graphing logarithms one at the end here, that's the new one where everything was all messed up because they're inverses of each other, so everything is backwards. All right, this is new stuff, but it's those application questions. And earlier you guys asked me, like, do we have to have these memorized, these formulas? Absolutely not, but you have to know how to use them. So this question, the population of a city is 816,000, and it's going to increase 2% per year. So on your test, you'll see this formula. What does A represent in this problem? Initial, which is what? 816,000. Now, in the formula, it has 1 plus or minus r. Your job is to figure out whether it's plus or minus. What you got? Why is it plus? Because it's increasing. Yes. 2%. How do you write that? 0.02. Very good. So if you're not sure how to convert that to a decimal, you can just take the percentage and divide by 100. And then to the t power, how much time are we going to let go by? 12 years. Now, guys, there are no more variables left in my formula. So we are in the home screen of our calculator, just typing away. And these are people. So where would be an appropriate place to round if we're talking people? A whole person would be nice. Thinking. What you got? Because I have no idea. You want a shout out for that? You know, for a kid who wants a sticker, you think he'd be typing. Come on. Well, it should be, it's growing, so it's in the millions yet? No? Yeah, okay.
1,034,885.
880.
Something like that.
885? Like this? Nice. No, in the home screen, kiddo, because there's no variables. Yeah, if you guys went to y equals and looked at your table, you're just going to get the same 1,034,000 all the way down the list, so. Yeah. Oh, it's okay. Maybe you should sit in your seat that you were assigned. Oh, with the front row seat? Is it because you're so close to the stickers? Okay. All right, suppose $3,200 is invested into account compounded daily, blah, blah, blah. All right, so on your paper, you're going to see this formula written down for you. You do not have to have this memorized, but you have to know how to use it. Yeah. So P stands for principal. That's your initial investment. What's our initial investment here for 7A? 3,200. Very good. And then 1 plus my rate, which is, as a decimal, 0.025. Yeah, watch. Everyone does that one wrong. I don't know why. Over, yep. Oh, I skipped 6? I sure did. We'll come back to 6 in a minute. What is 6, by the way? Is it the bacteria question? It's my favorite one. All right, we'll go back to it. There's some good bacteria in the world. All right, compounded daily. So we got 365. And then that 365 shows up again up in the exponent. Hey, my yellow calculators, you don't need to use parentheses here on the exponent, but you can. And we're supposed to multiply it by how much time has gone by. So 5 years. Just make sure you're multiplying by 5 right here. Oh, no, that's 6. Good call. Now, this is money. So where's an appropriate rounding for money? 2 decimal points, because money is dollars and change, usually. How rich are we? For the sake of time, I'm okay if someone just shouts it out if they already have it. I feel like it's bigger than that. Really?
3626.4. No. Yes. No,
I'm sorry, dear. You were dead on. I don't know why I thought it'd be bigger. Oh, it's only 5 years. Haha. Gotcha. We need to let our money sit around a little longer, guys. That's not enough money. All right. Back to number 6, which apparently I don't have a picture of. It's a bacteria question, yeah? Oh, for Pete's sake, I just saved it. Stupid. It's not bacteria? Oh. Oh, 6B is bacteria. Oh, okay. Well, 6A for the sake of consistency. So it says, again, on the test, it'll tell you to use this formula. You have to decide whether it's 1 plus R or 1 minus R. So the car is worth how much money right now? 10,000. Oh. Oh, we want it to be 10,000, huh? Gotcha, gotcha. All right. 5,600 is its initial value. And then is it going to increase then? So 1 plus, what's the rate? 7.2% in the problem, so 0.072 on the conversion, thank you. And then it says, when will it reach a value of 10,000? This is the one where I don't know time. So since I have a variable, we're going to need to use our table. So get this into Y1, and then you're going to use your table. And we're going to keep scrolling down until you can see a value of approximately it hit 10,000. It's not going to be exact, so you can tell me like between such and such year. Woo! So look for, it won't be exact, but close to 10,000 over here. All right, so 8 to 9 years. And that's our answer. I think the problem will even say, use your graphing calculator's table. So I just want to be very clear, guys. The act of you knowing how to use the calculator is actually what I'm testing. I cannot answer that for you tomorrow during the test. If you're like, I don't know where to go, that's yeah, you're getting the formulas and you're getting words like, yeah. When I tell you use your table, like you got to know what that means. All right, 8A. So see on this question how it says use your graphing calculator's table? That's my way of telling you to use your table. So we have birthday money. It collects 3% continuously invested in a continuous account. So I'm telling you to use your PERT formula. And this is the question where it feels like they didn't tell me enough information. How much money do you want to invest? $100 sounds good. It's what Meyer always invests. You can use anything you want here for the P. So I went with 100 because that's what you guys told me. And then E to the, how do you write 3%? 0.03. And it says, when will your money double? So I don't know the time. So again, I'm using my table. And I want my money to double. So what are we looking for on our table? $200. That would be the doubling of $100. So if you were on your own and you invested a different amount of money than 100, we're still going to get the same answer because you're going to have your money double. An error. That doesn't sound good. And you guys should practice typing this again because that's the skill. I can't help you with that tomorrow.
The X is in the same column as the decimal. It's not like another X in the button, right?
Oh, the 0.03 times X? No, it's 1. That is the exponent. So we're not going to get exactly 200, guys, but between what 2 years is it? Or is it closer to 1 than the other? 20 what? 23 to 24 years? Okay. Sounds good. All right. 9A. This is some new stuff. Logarithm formula going to exponential formula. This is really tough for me. So what I do is I figure out who the base is, and then I just remember the other two flip-flop. So who's the base in this original problem? Yeah, 9. So I write down the 9 as a base, and then I take the x and the 2, and I basically flip-flop them. So the 2 becomes the exponent, and then equals what? X. Good. That's all I'm asking you to do in number 9, is rewrite it into exponential form. So then number 10 is the reverse of that. I give you exponential form, I want log form. I hate this way. I don't know why. I think because I have to remember to write down log. So basically what I would encourage you to do on the test is just recognize that these are just opposite problems. So if you're trying to figure out what am I supposed to make it look like, just look at the next question. So it's a log of what base? Yeah, this is the base, which means he's still the base, 6. And then I just remember to flip-flop the order of these two. So what should I write down next? 216. The next thing would be 216 equals x. Very good. And then every time, even to this day, guys, and I've been doing these problems since before you were born, I still go back and I rewrite them in the other order just because that's the way my brain naturally thinks. You're all doing a quick math problem to figure out how old I am now, aren't you? Old. The answer is old. All right. Oh, gosh. Be quiet. Stop guessing. All right. Number 12. Number 12. This is what we were talking about earlier. This is the new graph of the logarithm. So everything we know about those exponentials, we got to reverse it, okay? Did I skip another set of questions or something? I skipped 11. What was 11? Oh, you know what? I didn't skip it. I think it's hiding behind something. Oh, not there. Here? Ah, there we go. Okay. Let me... Gosh, I did a terrible job of this. Let's try this. I know. Well, it was my bad. Thanks for the assumption that I just didn't do a terrible job. Oh, for Pete's sake. I don't know. We'll come back to that. All right. Number 11. Let's go to number 11. We're going to evaluate these logarithms. My brain does not think in terms of logarithms, but my brain can totally think about these in terms of exponentials. So this is where we said equals what? And then I'm going to rewrite it so my brain can think about it. So the base is 3. Raised to what mystery power gives me a 1? 0. Very good. This is that weird one. Anything to the 0 power is always going to give you an answer of 1. So if this shows up, automatic 0. That's the answer. So this next one. 4 to what mystery power will give me a 64. And you might have to try some stuff on your calculator. Shouldn't be a huge number, but I'm hearing 3 works. All right, and then here, ooh, what's that say, 5? So 5 to what mystery power will be 625? 4, I'm hearing. Uh-oh, they're going to get weird. What power could you raise 8 to that'll magically transform it to a 1 over 8? It has to be a negative. And I don't want to change the 8 as anything. So, will negative 1 do the trick? Yeah, 8 to the negative first. Or immediately it gives you a decimal, but we know it's really 1/8. All right, and then trick question here. Think before you speak. 7 to what power? We'll change that to a 1 over 49. So I'm hearing negative and 2. The negative reverses the fraction. And the 2 changes the 7 to a 49. Very good. All right, now we're going to graph. So we're graphing, and everything I knew about exponentials I have to kind of reverse. So while I drew a horizontal asymptote when I was graphing exponentials, now I have to draw vertical asymptotes. Can you tell me where the vertical asymptote is located in this question? At x equals negative 2. Very good. This is x minus h. So if you kind of think backwards about the built-in negative business, you have a vertical asymptote at negative 2. And it is so important that you guys understand what these are supposed to look like, because remember, these are the ones your graphing calculator does a really bad job of graphing. It's going to look like it stops. It's not going to give you a lot of points, so you just have to know. So you can graph this on your calculator, and I think you'll be able to give me like 2 points, maybe 3. It's not great. What you got?
8.
Yep, 8, 1. Negative 1, 0. And then if you look at your graph, it basically makes it appear like this, right? And if you draw that, I'm going to know that you don't know what you're doing. Because is that what a logarithm looks like? No. Even though my calculator makes it look like this is what the graph looks like, we know better. This actually comes down like this. So I'm going to be looking for the extension of that vertical asymptote along the tail there. Yeah, you have to like complete the graph, and that's a dead giveaway that you don't know what you're doing when you don't complete the graph, so please don't do that. Now with a better looking picture, you should be able to talk to me about your domain. Your domain begins at negative 2. Goes to infinity. Whoopsies. Negative 2 to infinity. What about range? Very nice. So we were talking earlier about how these were the complete opposite from the exponential. This time the range goes forever. The domain starts at the asymptote. Alrighty. One more topic, I think. Transformations of logarithms. They work the same as transformations of everything. Let's see if we can figure it out. Yes! Write 3 down 4. Very good. All you gotta do, write 3. R3. D4, down 4. You don't even have to write the words. I know what you mean. Now, you can try graphing these on your calculator to test out your transformation guesses or thoughts. But remember, your calculator does a terrible job of graphing these, so it's not going to help you very much. All right, we're going to stop the video. Thanks, y'all.